Hi, I'm Destiny Collins, and for this single math question, I will be your teacher, and I will be teaching you how to do question 7 on page 87 in the Nelson Advanced Functions textbook. The purpose of this video is for the viewer to learn how to do types of math questions like these that will occur in their Advanced Functions course. In order to fully understand this question, there are some terms you should know first. Feel free to pause the video now and read these terms if you do not already know them. Now let's begin. To fully understand the question, you must read it properly. I will read the question out loud and you can follow along. Question 7 on page 87, number 7. The population of a town in thousands is described by the quadratic function pt equals negative 1.5 x squared plus 36 plus 6, where t is the number of years after 2000. A. What is the average rate of change in the population between 2000 and 2024? B. Does your answer to part A make sense? Does it mean that there was no population change from 2000 to 2024? C. Explain the answer to part B by finding the average rate of change from 2000 to 2012 and from 2012 to 2024. D. What value of t is the instantaneous rate of change in the population 0? Important information. The most important part of this problem is the equation. Then you also need to realize the units. P is in thousands and t is the number of years after 2000. This question is directly related to Advanced Functions Unit 1, which is when you learn to do your AROC and IROC. This unit is called Functions and their properties and rates of change. So let's get started with the math. We will be answering the questions in order, so let's start with 7a. What is the average rate of change in the population between 2000 and 2024? Our plan for this step is to find AROC. I would recommend you writing the equation down first. Now let's convert the units from the question to the units in the equation so they are the same so we can solve. We know that 2000 is 0 when converted to t, because t is the number of years after 2000, and that is 0. Now we use that 0 that we just solved for and put it into the equation as t. This we will be doing using the substitution method. So now you just solve for the equation using BEDMAS. So we know that 0 squared is 0, and we know that anything times 0 is 0. So we can automatically cross out the 1.5t squared and the 36t, because we know that both their values will be 0. Then all we have to do is add 6. So there you have solved for it. P of 0 is equal to 6. This means that in 2000 there are 6,000 people. Now do the exact same thing with 24. If you need to, rewind the video and listen to the steps again. They are also listed on the side for your reference. So now that we have found both the t values for the years 2000 and 2024, we can put them into the AROC equation. The AROC equation is the exact same as the slope and the IROC equation, which is y2 minus y1 over x2 minus x1. The first step to finding the answer is to determine your values. So y2 in this case is going to be 6, y1 is also going to be 6, x2 is going to be 24, and x1 is going to be 0. Now once again you substitute these numbers into the equation and solve using BEDMAS. So 6 minus 6 is 0, and we know that anything divided by 0 is 0. So now we can already tell that the final answer is 0. Now, although we have finished the question, it is important to remember your therefore statement, which summarizes the information that you solve for. So the answer to 7a is, between the years of 2000 and 2024, the population is 6,000, and the average rate of change is 0 people per year. 7b. Does your answer to part A make sense? Does it mean that there was no population change from 2000 to 2024? Yes, my answer of 0 for the average rate of change from 2000 to 2024 does make sense. This is because both populations are 6 and they are exact same, which means it does not change. Now, if you're wondering how we know this, it is because we just solved this question in 7a, and we are just further expanding on what we know. So we know that the average rate of change is 0, which means there must be no change. Explain the answer to part B by finding the average rate of change from 2000 to 2012 and from 2012 to 2024. So part B told us that the population did not change, and we can further expand on this by solving from the AROC from 2000 to 2012 and from 2012 to 2024. So in 7a, we already solved for the population in the years 2000 and 2024. So now we are just going to do the exact same substitution process, but for the years 2012. So this time t will equal to 12. So refer back to slide 5 if you do not remember the process, but the steps are also listed on the side for your needs. After solving this, we know that the population in 2012 is 222,000. So now that you know the population in the year 2012, you can now do the exact same AROC method that is on slide 7. If you do not remember, you can rewind the video and listen to my explanation, or you can follow the steps listed on the side. But remember, you have to solve for the AROC from 2000 to 2012 and from 2012 to 2014 separately. So on this slide, we did from 2000 to 2012, and we saw that the average rate of change was 18,000 people a year. Now do the exact same AROC process with the steps listed on the side, but from the years 2012 to 2024. After you solve this, you will notice that the average rate of change from 2012 to 2024 is negative 18,000 people a year. D. For what value of t is the instantaneous rate of change in the population 0? So before we start to answer this question, we need to think critically about what we've already solved. So thinking about quadratic functions in general, we know that we can graph it. And this one from this question would look like a parabola, with 12 being the vertex at the highest point and 0 and 24 being lower towards the x-axis. In the diagram below, I have graphed the quadratic function so you can get a general idea of what the answer for this question is going to be. By looking at the graph, we know that 12 is going to be the highest point, and we know at the vertex of a parabola, the slope is 0. And when the slope is 0, the instantaneous rate must also be 0 because the equations are the exact same. But we cannot just solve for an answer like that. We must solve it mathematically. Instantaneous rate of change is at one specific moment. In this case, it is 12. But you still need two points to solve for it mathematically. So for instantaneous rate of change, you add 0.001 and subtract 0.001 from 12. So now you do the exact same thing you did on slide 7, where you sub in the x values into the equation to solve for the y values. Do this for both x values. So once you've solved for one, solve for the other. So before you did 12.001, so on this side you're doing 11.999. Remember to use BEDMAS, otherwise you will not get the correct answer. Now once you have both x and y values, you can now solve for the IROC the exact same way you would solve for AROC, subbing the x and y values into the equation and solving. In this case, because the numbers are so close, they subtract to 0, and you know that anything divided by 0 is 0. Therefore, we can determine that the IROC is at 0 when t is equal to 12. Congratulations, you have solved the entire question. Now, I know you're wondering, how does this relate to anything? Well, actually, there are careers that relate to this type of population question. For example, the city planner. A city planner needs to be aware of a population because they need to provide facilities, infrastructures, and support their needs. Also, government determines how many immigrants should be allowed into this country, which heavily influences the population. So when the population is low, they would allow more immigrants in. This is how it relates to city planning. Here is a picture of what a city planner does in their daily life. Thank you for watching this video. I hope you have learned a lot. Remember, if you still do not understand the math process, you can rewatch this video again or practice. Practice always makes perfect. The more you do these types of questions, the more you will understand them. Thank you. Have a great day.